Okay, so this problem deals with geometry. Okay, so the formula here that we need is 2 pi r squared plus 2 pi rh equals the surface area. So for this particular problem, the surface area is given to be 381. In place of this height right here, we're going to put 11. Okay, and so we have 2 pi r squared plus 2, and we can go ahead and make this. Let me erase. All right, I'm going to go ahead and make that 22 pi r equals to 381. Okay, and then we are going to subtract over the 381. So we have 2 pi r squared plus 22 pi r minus 381 equals 0. That's a quadratic. I know that because I have r squared there and r there. So because of that, it's a quadratic. And here, the first thing you want to do is see if, by any chance, everything is divisible by 2. Sometimes it is, sometimes it's not. Here it's not, so we're just going to go ahead and solve this quadratic. So remember, A is what sits in front of the quadratic term, B is here, and C is here. So A is 2 pi, B is 22 pi, and C is negative 381. And so we're going to apply the quadratic formula, which is the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2A. So that's a bit of a bear, but we're going to plug that into our calculator. Okay, so we get 4.03 centimeters. You'll notice that there's only one answer. You have to disregard the negative. So here, when you take a negative and a negative, that would give you a negative in the numerator, and we know that a radius cannot be negative, so I disregarded that solution, and I only did the positive. So the negative 69.15 plus the 119.8 gave me the 4.03. Sorry. So that's it for that problem. Okay, and now for the next one. So for the next problem, we have a formula that's given. S equals negative 2.7 t squared plus 50t plus 6.5. So that formula is given to us. S is the height of the ball. Okay, that's given, and then t is the time. So in this problem, it wants to know after how many seconds. So in other words, it wants to know how much time. So after how many seconds is the ball 20 feet above the moon's surface? So they're telling us that the height is 20 feet. So we just have to plug that in. So we have 20 equals negative 2.7 t squared plus 50t plus 6.5. Okay, and then we want to solve that quadratic. So similar to the last problem, we're going to shift our constant over. So we have negative 2.7 t squared plus 50t. And then we're going to take our 6.5 and we're going to subtract the 20, and we come up with negative 13.5. So there's our quadratic. A is negative 2.7, B is 50, C is negative 13.5. So you just plug that into the quadratic formula. So you have negative 50 plus or minus the square root of 50 squared minus 4 times negative 2.7 times negative 13.5 all over 2 times negative 2.7. So once you plug into the quadratic formula, now you just plug that into your calculator. Okay, and so when you're plugging into your calculator, you want to make sure that you take into account both the positive and negative. So we're going to do negative 50 plus 48.52 divided by the negative 5.4. And then we're going to also do the negative. So negative 50 minus the 48.52, okay, divided by negative 5.4. So let's go ahead and enter that in. So we have negative 50 plus the 48.52 divided by negative 5.4. I come up with 0.27. And then for the other, we have negative 50 minus the 48.52. And then we're going to divide that by the negative 5.4. I come up with 18.24. So the ball will be at a height of 20 feet at 2 points in time at t equals 0.27 seconds and t equals 18.24 seconds. And that should make sense because when you're dealing with a projectile that's quadratic, so at a height of 20 feet, which is right here, you have on the way up it would be 0.27, and on the way back down it would be 18.24 seconds. All right, and then similar for part B, a similar process, but here it wants to know when the ball is at ground level. So instead of 20, you're going to repeat the whole process with the height being 0. I hope this helps.